Oke. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good afternoon, everyone. So today we will learn together about geometry transformation. For that, let me introduce myself. My name is Restu Rahman. NIM 220106220002. This is my 5th semester. My study program is Mathematic Education from Universitas Muhammadiyah Purwokerto. So, what is geometry transformation? In mathematics, geometric transformation refers to the operation that moves or changes a geometric figure in some way to produce a new figure. Transformations are classified into 4 major types. The first one is translation, the second is reflection, the third is rotation, and the last one is dilatation. This transformation can change the position, orientation, or size of the original figure, known as the pre-image, to form a new figure called the image. The first one is translation. Definition. Translation moves every point of a shape the same distance and in the same direction. The shape does not change its size, shape, or orientation. Only its position is affected. So, in translation, the shape of the object is not changed. It's only the size, shape, or orientation. It's only the position of the object is affected. The formula of translation. If we translate it to the right and up, so the operation is addition, plus. And if we translate it to the left and down, the operation is subtraction. Next. So we go to the example. Let's say we have a point A, 5 and 7. And we want to translate it 7 units to the right, 7 to the right, and 4 units down. So the new position of point A is, we must notice that we translate it to the right and up, the operation is addition, and if we translate it to the left and down, the operation is subtraction. Next. So the example is translate 7 units to the right, so the operation is plus addition, and 4 units down, so the operation is minus. Seven unit to the right, so the operation is addition or plus, and the second one is 4 unit down, so minus subtraction. So the position of point A is 12 and 3. You can see that in this picture. The first position of point A and the new position of point A after translation. So the next one is reflection. Definition of reflection. Reflection creates a mirror image of a shape over a line called the line of reflection. Every point on the figure is the same distance from the line as its image, but on the opposite side. We can see this picture. So this is the object and this is the mirror. After we reflect it in the mirror, the object is right here. So it's the opposite side from the first position of the object. Next one is characteristic of reflection. The distance from the point to the mirror is the same as the distance from the image from the point to the mirror. The reflected object face each other. So we have reflection across x-axis. If the point A is x and y is reflected on the x-axis, the image is A accent x and minus y. We will to notice and remember this. If the point A, x and y is reflected on the x-axis, the image is x and minus y. For example, reflect point A. We have point A and 5 across the x-axis. Across to x-axis. The x coordinates stay the same. We need to remember this. The x coordinates stay the same and the y coordinate change its sign from plus into minus. So the new coordinates for A is 8 and minus 5. This is reflection across its axis. We need to remember this. Across its axis is x and minus y. And then reflection across y-axis. If point A, x and y is reflected on the y-axis, the image is minus x and y. So it's different with the across x-axis. The x-axis is x and minus y, and then the y-axis is minus x and y. For example, reflect point A. We have point A, 5 and 6 across the y-axis. So we need to remember the formula. If point A is reflected on the y-axis, the image is minus x and y. The y coordinate stays the same and the x coordinate changes its sign. So we have the new point A is minus 5 and 6. So this is a reflection if across the x-axis and across the y-axis. Next. So the third part is rotation. The definition. Rotation turns a figure around a fixed point called the center of rotation. The angle of rotation determines how much the shape rotates, and the direction can be clockwise or counterclockwise. The direction of rotation. So, the direction of rotation counterclockwise is positive. The clockwise direction of rotation is negative. For example, rotation with center 0.0 and the angle is 90 degrees. If point A, x and y is rotated equal to origin 0 and 0 by 90 degrees, then the image is minus y and x. You can see the answer in the picture. The first example is point A, 2 and 1. If we rotated about the origin center 0.0 by 90 degrees, the image is minus y as x. So the x is stay the same, 2 and it's 2, and the y is changed its sign as minus y. So we have the rotation of this object from point A to N1. After we rotation this from center 0.0 and the angle is 90 degree, we have a axis -1 and 2. We need to remember this formula of rotation. And then the second one is rotation with center 0.0 and the angle is -90 degree. If point A, x and y is rotated about origin 0.0 by -90 degree, then the image is ax and y and -x. So this is the opposite for we learned before. This is the angle is -90 degree. So for the example is see this picture. We have point A, 2 and 1. We have to rotation this point with center 0.0 and the angle is -90 degree. So the rotation is going down. From formula we have ax is y and -x. The first point we have 2 and 1. So for the ax we have 1 and -2. So this is the picture after we have rotation with center 0.0 and the angle is -90. Now the third one is rotation with center 0.0 and the angle is 180 degrees. If point A, x and y is rotated about origin 0.0 by 180 degrees, then the image is ax is -x and -y. For example, we have point A, 2 and 1. We need to have the rotation with center 0.0 and the angle is 180 degrees. From the formula, the image is ax -x and -y. We have 2 and 1, so the ax is -2 and -1. So this is the first point of A, 2 and 1, and after we rotation with center 2 with center 0.0 and the angle is 180 degrees, the new position of point A is right here, -2 and -1. Now for example, suppose we have the triangle at coordinates A 2.2, B 4.2, and C 3.5, and we want to rotate it 90 degrees clockwise around the origin 0.0. Rotate 90 degrees clockwise. New coordinates for each point after 90 degree clockwise rotation is So we have point A, 2 and 2. Point B, 4 and 2. And C is 3 and 5. So this is the triangle we have. And then we want to rotate this 90 degrees clockwise, and the origin is 0.0. So the new position of A after we rotate it 90 degrees clockwise is -2 and 2. And new position of point B is -2 and 4. And the new position of point C is -5 and 3. So this is the picture of the triangle ABC with A is 2 and 2, B is 4 and 2, and C is 3 and 5. After we rotation this triangle 90 degrees clockwise, and the origin is 0.0, is like this. With the A accent is -2 and 2, the B accent is -2 and 4, and the C accent is -5 and 3. So the last one is dilatation. Definition of dilatation. Dilatation changes the size of a figure without altering its shape. A scale factor greater than 1 enlarges the figure, while a scale factor between 0 and 1 shrinks it. The figure is dilated from a center point. So this is the formula of dilatation. The image of point A, X and Y by dilatation with center P, A and B, and scale factor is K, is A accent equals K X minus A plus A, and K Y minus B plus B. K is ratio of line segments, and A and B is center of dilatation. For example, consider a square with vertices at 1 and 1, 1 and 2, 2 and 1, and 2 and 2, and we want to dilate it by a scale factor of 2 both the origin. So the first one is multiply its coordinate by the scale factor 2. So the first one, 1 and 1, is multiplied with 2. So we have the 2.2. And from 1 and 2 multiplied by 2, we have 2.5, 2.4, and the third one is 2.1, and multiplied by 2, we have 4.2. And the last one, 2.2, we multiply by 2, so we have 4.4. So that is the presentation today. For that, I want to give you a student worksheet about geometric transformation about this material today. So I want you to work this student worksheet in a group. One group is 2 students. So I want to give it to you. Are you finished?
Finish.
Okay, so I'll take it from you.
Okay, this is.
Okay. So that is the material for today. Before we close this class, any question?
No.
So for ending this class, let's say Alhamdulillah together.
Alhamdulillahirabbil alamin.
So that is for today. Assalamualaikum warahmatullahi wabarakatuh.